All right. Yesterday we started to introduce some trig identities, like certain equations that we know are true, and we can use those identities to help us simplify kind of complicated trig expressions. So we're just going to have more practice today and tomorrow and the next day, just getting used to manipulating these expressions. So those identities or true equations can be found on page 419, I believe. We went through all those yesterday.
Good morning.
Good morning. Anything for the office today? I think we're good. Okay, thank you. Before we pick up where we left off, seniors, this is your last week, and I've heard through the grapevine that there's going to be some illness going around on Friday. Is that right? Mm-hmm. Okay, so unfortunately, I wish you well. Hopefully you don't get too sick, but if I don't see you, I completely understand. So we will not be getting to the quiz in time.
Please excuse the interruption. Will all students taking the Keystones please report to their assigned areas? As all students please report to their areas for the Keystones. Also, I need Byron, Geyer, and Savannah Yard to report to the cafeteria. Thank you.
All right, good luck, guys. Last one. Make it count. All right, so anyway, we're not going to be able to make the quiz in time before you guys have your illness on Friday. So what I'm going to be doing is going to be collecting your homework that we've that we have covered up to this point on Thursday, which is technically your last day here. So that's only 2 homework assignments. I forget what pages they're on, but if you look at the little table for this last unit, they should be listed. There's going to be the 1 homework assignment from the periodic functions, okay, from the very first section we talked about. And then we're probably going to finish this section today, if not definitely tomorrow. So the homework from this section will also be due. Okay, so just 2 homework assignments due on Thursday for you seniors. All right, juniors and everyone else, we're just going to roll through the rest of the year. Okay? All right. So I believe yesterday we left off on the next page after the identities. Did we finish this bottom left-hand one? No. Did we do the top right-hand one? Yes. We did that one? Okay. All right, so let's take a look at the bottom left-hand one. In relation to the top 2 that we did yesterday, we used one strategy for these 2, and that was rewriting everything in terms of sine and cosine. That's a good strategy to have because it eliminates working with 3 or 4 different trig functions down to only working with 2. So that's one way you can use a strategy to help you simplify. Sometimes, though, rewriting in terms of sine or cosine, bless you, can get pretty ugly, especially when you get into secant and tangent, cosecant, cotangent, because we know rewriting those in terms of sine or cosine is going to result in fractions. For instance, 1 over cosine or sine over cosine. So we don't want to maybe rewrite sine and cosine every single time because you're going to encounter a multitude of fractions. At first glance, though, maybe we can use an identity to help us simplify it. So another strategy to help you, perhaps, is whenever you see those squareds going on, you could probably use an identity to help you rewrite it. Because the last 3 identities we discussed yesterday had some type of trig function being squared. So there's like a little clue or hint for you to look for. I think, like I said yesterday, I can't give you a process to use every single time we do these examples because it's going to change. Depending on what you're comfortable with algebraically, what you notice first, or what identities you're even able to use. So unfortunately, these are kind of like a crapshoot, okay, for lack of a better phrase. Okay, you just have to approach them with a good attitude and just keep working through them until you kind of reach your end result. So taking a look at the first one here, is there anything written that we could probably use an identity for? Yeah? Okay, so an identity from yesterday. We had this 1 plus tangent squared equals secant squared. In our example, though, we have secant squared minus tangent squared, and that was one of our manipulations. Okay, when we took this main identity and just rearranged some terms. So secant squared minus tangent squared happens to be the same thing as 1. So we'll definitely use that identity. So this entire top up here, using the identity, would change to 1. That's a pretty big simplification, because we go from having this complicated stuff down to just the number 1. That's why identities are useful, because they simplify or make things a little bit easier to work with. Can we rewrite secant, though? Pencil had a mind of its own. Yeah. 1 over sine. Good. All right. So the entire top, we could use an identity that would simplify to 1. And the denominator, even though we don't have anything squared there, we couldn't use one of the Pythagorean identities, but we could rewrite cosecant as 1 over sine. So from here, how can we keep simplifying? We have a bunch of fractions. What are you going to do, Tori? There we go. So instead of dividing by a fraction, you can bring it up and multiply by the reciprocal. 1 times sine over 1 is just going to be sine. So this craziness we actually started with, which looks kind of confusing and complicated, is actually the same thing as sine. Okay, this is why the identities are useful, because we can use them to simplify something and therefore help us solve something. Okay, so simplifying is our first step to help us solving some complicated equations. What about number 2? Let's maybe start with the top. We can rewrite cosecant as 1 over sine. Okay, just like how we did the previous one. What about the denominator? I see something squared in there, so we probably could use an identity. Let's check to see if there is actually one that would work. Yeah.
You could simplify 1 plus cotangent squared.
Okay.
Cosecant.
Cosecant. All right, so this is an identity from yesterday. Using the last one, number 7, 1 plus cotangent squared is cosecant squared. Can we rewrite cosecant squared? Let's see, if a single cosecant was 1 over sine, what about a cosecant squared? What do you think, Tori? 1 over sine squared. Good. All right, multitude of fractions. So let's clean it up. Instead of dividing by a fraction, we can bring it up and multiply by the reciprocal. And multiplying fractions straight across the top, straight across the bottom, we'll have 1 times sine squared for the top, and then sine times 1 on the bottom. Looks like we can cancel out a pair of sines, because we have 2 up top and 1 on the bottom, and we're just left with sine. So we actually happen to get sine for both of these in the end, which means these complicated ones are actually equal to each other, even though they look different. They simplify to the same thing. We're doing okay from yesterday? Using some identities to help us rewrite these expressions? Okay, we're just going to keep trying more of them. Okay, practice, practice. It's the only way we're going to get comfortable. All right, let's try the next one. Tangent, maybe we can rewrite that in terms of sine or cosine. Do you remember from yesterday our kind of identity for tangent, how it's related to the other trig functions? Yeah. There we go, sine over cosine. Now I know we have alpha in our problem. Maybe we'll change those to x's because alpha for some of us can be a little difficult to write. So we'll change them to x's. All right, so we rewrote tangent. Can we rewrite 1 plus cotangent squared? There's a little squared in there. Maybe we can use an identity. Yep. Cosecant squared. And that's all over cotangent. How can we rewrite cotangent in terms of sine or cosine? I heard it. We got cosine over sine. All right. Where do you guys want to go from there? We could do a bunch of different things. Depends on what you're comfortable with, what you see first. Any preferences? Yeah.
Well, if you can simplify cosecant to 1 over sine of x, so that way that cancels out.
Okay. Well, this would be 1 over sine squared of x, right?
Yeah.
Okay. Good. And what did you say would cancel out?
Well, at least one of the top version of the sine.
All right, so that sign up top will cancel out with one of the signs down below. So we no longer have 2 there, we just have 1. So we have 1 over cosine x sine x all over cosine over sine. I like it. Can we keep going? Yeah.
Multiply by the reciprocal on
There,
the bottom.
there we go. Bring up the bottom, multiply by the reciprocal. So that's no longer there. Multiplying by the reciprocal, notice how a sign up top will cancel out with the sign down below. So those are gone. And we're left with 1 over cosine times cosine, so that we can write that as cosine squared. Can we rewrite 1 over cosine squared, though? Instead of having a fraction, can we leave it as 1 trig function? Good, Rebecca? Secant squared, good. All right, let's keep trucking. Rewrite each of the following in terms of a single trig ratio. All right, so they're kind of cluing us in, at least to these examples, that we should only have 1 trig ratio left, like just sine, just cosine, just tangent, something like that. Okay, so this complicated mess can be broken down into just 1 trig function, and we're going to try to figure out which one it is. You kind of have a 1 in 6 shot because there's only 6 trig functions, but we'll see how it works out. How can we rewrite secant in terms of sine or cosine? Yeah, 1 over cosine. All right, so then that means cosecant would be 1 over sine. And then tangent, we got sine over cosine. All right, let's try to clean it up. When at first glance here, we have 2 fractions being multiplied together. So multiplying fractions, we can go straight across the top, straight across the bottom. We'll turn it into 1 fraction. So 1 over cosine theta, sine theta. And then we still have sine over cosine on the end. Where do you want to go from there?
Well, in order to subtract, you can multiply both the top and bottom of the second fraction by sine.
by sine. All right, so we have one fraction minus another fraction. In order to subtract fractions, you need to get a common denominator. They need to be exactly the same. Notice how they both already have a cosine in them, but the left one has a sine and the right one doesn't. So we have to throw in a sine theta into the bottom of the second fraction. So that means we have to do that or throw it in at the top as well. So our new common denominator will be cosine and sine down below. Our numerator will just subtract the tops. We're not changing the first fraction, so it's going to stay a 1. And then we need to subtract sine times sine, which would give us a sine squared. So this is good. We originally had 3 fractions, then we simplified it down to 2, and now we have 1. We got to keep going though, because we supposedly should only have one trig function left. Where do you want to go from there? Do you see something, Tori? Yeah.
The top simplifies to cosine.
All right, there's an identity. All right, so this was our Pythagorean main one from yesterday, okay, number 5, that we had to circle or star. The main one is cosine plus sine squared is 1, but we had these manipulations if we wanted to move some terms around. And notice how 1 minus sine squared ends up being cosine squared. So we can rewrite the top, like Tori said, as cosine squared. What's going to happen from there? Yeah.
You can cancel out the cosine, and you get cosine over sine.
All right, so set of cosines cancel. We're left with cosine over sine, which is the same as which trig function? Yeah, cotangent. There's our single trig function that's left. We doing okay? Okay, it's just algebraic manipulation, fraction work, canceling things out, common denominators, but also using those identities to help you keep going or working through it. All right, let's try the next one. At first glance, there aren't any squareds in there, so we can't really use an identity just yet. Not to say that we can't use one in the future, okay, but for right now, we don't really have that strategy. So that must leave the only other thing we can do, or another strategy, is to rewrite everything in terms of sine or cosine. So let's start by doing that. Secant, we can rewrite as 1 over cosine. Cosecant is 1 over sine. And that's all over 1 plus tangent. But tangent is sine over cosine. We have fractions galore. All right, let's try to simplify some fractions. If we look up top, okay, we're adding 2 fractions together, so we need to get a common denominator. A simple way to kind of do that is take the opposite denominators and multiply them by either fraction. What I mean by that is take this denominator of sine and multiply it on top and bottom of the first fraction, and then the cosine denominator can be multiplied by the second fraction. Are we familiar with that little kind of shortcut to get a common denominator? All right, so our top fractions can change. Our common denominator is cosine sine, and the numerator would end up being sine times 1, which is just sine, plus 1 times cosine, which is just cosine. All right, so that's a good step because we went from having 2 fractions up top down to 1. Maybe we can do the same thing down below. We have 1 plus sine over cosine. We can change 1 into a fraction by multiplying cosine up top and bottom. That way we have a common denominator. So that common denominator will be cosine. And our tops we'll have cosine times 1 plus sine. Are we doing okay so far? It's fraction work, which I know we're used to, at least with numbers, but now we're throwing in trig functions, which to us might seem a little complicated. All right, where do you guys want to go from there? So many fractions. What do you see? Yeah.
You take the reciprocal of the bottom.
Yep. Let's bring it up. Instead of dividing by a fraction, we can multiply by the reciprocal. So that's no longer there. What's going to happen? Yeah.
Everything cancels out except for the sine x on the bottom left, so it's 1 over sine x.
There we go. All right, so cosine up top cancels out with cosine down below. Sine plus cosine in the top is going to cancel out with a sine plus cosine down below. Those are exactly the same. So Tori said we're left with 1 over sine, which is, we want a single trig function. No fraction. Good, Rebecca?
Sine x?
Say it again.
Sorry, not cosine. Cosecant x.
Cosecant x. There we go. The other C one. Good. All right. Practice, practice, practice. We're going to try some more. Are we going too fast? Too slow? Hanging in there? Feel like Goldilocks? All right, let's try the next one. At first glance, there aren't any squareds, so we probably can't rewrite any of those using identity. That doesn't mean we can't do it in the future. We just can't do it right now. So let's see if we can maybe rewrite them in terms of sine and cosine. So secant is 1 over cosine, and that's all over sine. And then for the next one, we're subtracting secant, which is 1 over cosine, divided by cosecant, which is 1 over sine. All right, fractions galore again, so maybe we'll just work with one piece at a time. If you look at our first fraction, okay, we've kind of two fractions going on here because we have the main one up top and then the overall one together. Instead of dividing by sine, we can bring that up and multiply by the reciprocal, which would be 1 over sine. So that's going to turn that crazy fraction into one simpler fraction. If we multiply across the top and across the bottom, we'll have 1 over sine cosine. All right, if we do a similar step for the second fraction, instead of dividing by 1 over sine, we can bring it up and multiply by the reciprocal. So we'll be left with sine over cosine. It's starting to look nicer because we don't have all these fractions going on. Now we're just down to 2. Where do you want to go from there? We need to subtract 2 fractions. Yeah?
And we multiply by sine to get the second one.
There we go. Okay, we'll multiply by sine on top and bottom for the second one. That'll give us a common denominator of sine cosine. And our numerator will be 1 minus sine times sine, so we can write that as sine squared. We're still looking for a single trig function in the end. We're getting there. We went from a crazy amount of fractions down to 2 fractions. Now we're down to 1, so we're simplifying it. What's good? Where do we want to go from there? Yeah.
You can simplify the top to be, I think, cosine.
cosine squared x. Good. Okay, well, that's one of our identities. That was a manipulation of the Pythagorean identity, the main one from yesterday. And that's all over sine, cosine. So it looks like we can, go ahead, Marie.
Cross out one of the cosines.
Cross off a pair of the cosines. So we're left with one cosine up top. So cosine over sine, what's our one trig function? Yeah, cotangent. Perfect. All right. So far, so good. Let's see if we can get this last one in before the bell rings. We'll save the bottom one kind of as a review for tomorrow. Let's see. Where do you guys want to go with this one? I'll let you kind of talk our way through it. Can we start rewriting? How can we rewrite secant? 1 over cosine. Good. Minus cosine. Okay, that one doesn't have to be changed. What about the bottom part? We can approach this multiple ways. I know you guys notice the squareds in there, so you're probably thinking, oh, I might be able to use an identity, right? Okay, that's a little hint. You could rewrite sine squared. That would be 1 minus cosine squared. That's one thing you could do. You could rewrite secant. Let's see what that one was. Secant squared was 1 plus tangent squared. Okay, so one route you could do is using the identities. Another route you could do is rewriting them in terms of cosine or sine. For instance, we can keep this one as sine squared. And then we can rewrite secant squared as 1 over cosine squared. I can't tell you again what to do because it's all about what you notice or what you see first or what you're comfortable with. Yeah?
Now, if you have that, do you have to distribute it or can you cross out? Oh, 1 over cosine.
You mean this thing?
Do you have to distribute it?
I would. I would move this to the top. Well, we might eventually be able to cancel something out, but I would wait until we're for sure able to do that. Okay? Now, again, you could use an identity. It might get a little complicated. That doesn't mean it won't work. Okay? It just depends on how much you're going to have to work through it. So some of these, when you're going through the homework, might be a little frustrating because you're not sure what to do or when to do it. Okay? But you just got to have a good attitude about it and keep trucking, or at least keep trucking through it. So if something doesn't seem to work, maybe go back and try a different strategy. Perhaps instead of using an identity, maybe rewrite in terms of sine or cosine. Okay, you have all these strategies, and what's difficult is when to use what or when to do what. Okay, but don't get frustrated when you're going through them. All right, so I like Marie's idea. Let's go ahead and move the sine squared to the top of that bottom fraction. Think about distribution, I guess. Yeah.
Would that equal tangent squared?
It would equal tangent squared. Okay, but we're going to keep it in terms of sine and cosine just because maybe we can cancel out something up top. Okay, but that definitely is tangent squared. All right, so we have one fraction in the bottom, which is great. Maybe we can get one fraction up top. That way we can bring up the bottom fraction and multiply by the reciprocal. So we are subtracting two things. One of them happens to be a fraction. So we should think about turning the other term into a fraction and getting a common denominator, going through all that algebra work. So common denominator, we'd have to multiply the second fraction by cosine on top and bottom. That would leave us with a common denominator of cosine. The new numerator would be 1 minus cosine squared. And that's all over sine squared over cosine squared. Again, fractions galore, but maybe you guys see something that's kind of taking shape that might use our advantage. Yeah. That's an identity. There we go. All right, so we can use this as sine squared over cosine squared. All right, let's perhaps, I'm going to rewrite this a little closer here. Instead of rewriting the division of this fraction, how about we bring this fraction up and multiply by the reciprocal? We could probably do that at this point because we have two fractions left. And things are going to cancel. Sine squareds are gone. And we can cancel out a set of cosines. So it looks like all we have left is a cosine theta. Again, these are best served with practice. Okay, we got to get used to working through these, maybe getting stuck, erasing, trying something else, but eventually we should get something much simpler in the end. Okay, we're going to try the last one for tomorrow and even more practice the next few days. Okay, just so we can get some comfortable feelings with these.